So in order for us to solve these equations, we know they have to be in factored form, right? We need those sets of parentheses. So today we're going to look at getting trinomials to be in factored form, how we can set it up so that they will be the two sets of parentheses so that we then in the future can solve them. They don't have to just give us the sets of parentheses in the already factored form. So before we talk about that, I just wanted to talk about what a trinomial actually was. So it's just a big fancy math word for a polynomial with three terms. The tri literally stands for three. So it's just a polynomial with three terms. So we're specifically only going to look at things that have three terms in them today. So this is just a polynomial with three terms. So we've seen a monomial, which was a polynomial with only one term. We've seen a binomial, which was a polynomial with two terms. Now we're going to look specifically at a trinomial, which has three terms. And when we're talking about trinomials, we like to write them as x squared plus bx plus c, where b is going to be a number and c is going to be a number. But if we were writing them in standard form, we want the x squared to come first because that has the biggest exponent. Then we want the term that just has an x to come next. And then when the last term will always be the term that's just a number. So our trinomials are going to be things that have three terms. The x squared will always be the first thing when we're writing it in standard form because we want that biggest exponent first. And we're going to take these and we're going to actually put them into factored form so that we can then solve them no matter how they give them to us. So we want to get them set up like the questions that we were solving last class and like the questions we just did in the do now so that we can actually solve them. So in order for us to factor these, we're going to first ask ourselves, what are all the factors of C? And C is always going to be our last number, our number that's all by itself, our constant that doesn't have any variables. And a factor is just a fancy math word for numbers that multiply. So we're just going to look for all the numbers that multiply together to give us C. And we're going to list those all out so that we can see them. And then we're going to ask ourselves, we're going to pick one specific set of factors, and the way we're going to pick them is we want those two numbers that add together to give us b, which will be our middle number next to our x. So the next thing we're going to do is pick the set of factors that add to b. And then we're just going to write our two sets of parentheses with our factors that we picked. So we're always looking for numbers that multiply to the last part, that's C, and add to the middle. And it'll make more sense. We're going to look at examples with actual numbers so that'll make more sense. But it's always the last number is the multiply, the middle number is the add. And that's where I see the most mistakes is people switch which one they're adding to and which one they're multiplying for. So that's the last one is multiply, the first one is add. It also goes in alphabetical order, add, multiply, right? A comes before M. So the first number we want to add to, the last number we want to multiply to. So these are going to be things that look like factor x squared plus 10x plus 6. So we want to factor the trinomial x squared plus 10x plus 6. Because right now we don't know how to solve x squared plus 10x plus 6. But if we can get it to be two sets of parentheses, then we can use our zero product property in order to actually solve something like that. So we're just going to work on today getting it set up to be two sets of parentheses. So the first thing we want to do is we want to know all the factors of positive 6. So we want factors of 6. And I know I want them to be positive because I have a plus sign in front of my 6. So when I list my factors, I like to always start with the very basic. We know 1 goes into everything, right? So I say, okay, 1 and 1 times 6 gives me 6. So my set here would be 1 times 6. Then I go, okay, and I literally just go in order. So I used 1, now I'm going to use 2. 2 goes into 6, yep. 2 times 3 gives me 6. And I don't have any other factors. If I wasn't sure, I could check 4, but I know 4 doesn't go into 6. I could check 5, 5 doesn't go into 6. And then I'm at 6. So those are all my possible numbers that I could have as factors. I also know, if I was looking at it, there are no numbers in between 2 and 3. No whole numbers in between 2 and 3. So once I get factors, as I work my way to closer and my factors are super close together, if there's no more numbers in between there, there's no more factors. Does that kind of make sense? Or I could say, like if I was going to write all the numbers 1, 2, 3, 4, 5, and 6 are all the numbers from 1 to 6. My first set of factors are 1 and 6. Then I have 2 times 3. So because 2 and 3 are right next to each other, then I'm done finding all my factors. So you could always like list all the numbers, which would probably take a long time. For some of these, if we're dealing with like 45, you don't want to write down every number to 45. But if you start on the outside and work your way in, once you've gotten two factors that are like right next to each other, you know you've found all of your possible factors if you just stay in order. Anyway, once we found all of our factors, then we want to look at our two options, because we're not going to use both of them to solve the problem. We want to look at our two options and say, okay, factors of 6 that add to 10. One plus 6 gives me 7. So that's no good. 2 plus 3 gives me 5. So that's no good. Since neither of my factors add to 10, I cannot break this up. There's nothing I can do here. This is already as simplified as possible. I can't go any farther. So the first thing I always do is I check my last number, pick out my factors, and then I want to see which one adds to the middle number. I don't have that option, right? I have a 7 and I have a 5, so I can't factor this. That could happen. It happens actually a lot more than it doesn't. So if you can't add to the middle, this is one of our no solutions. Or you could say not possible, not factorable. This is not something that we can factor. because I don't have any numbers that multiply to 6 and also add to 10. Let's look at the next one. The next one says, I want numbers that multiply to positive 12 and add to negative 8. So we want to multiply here, and we want to add to negative 8. So I always like to write my factors off to the side. You could even, if you just wanted to, put your number that you're trying to list your factors for, and I always like to list all of mine so that I can then, after I list them, go back and pick out which ones add. So again, I'm going to start with 1 times 12. But I also noticed that I need a negative 8 here. So if I'm going to get numbers that add together to be negative 8, I'm going to need negative numbers, right? So 1 times 12 gives me positive 12, but I can also use negative 1 times negative 12 to get positive 12. And I'm probably going to need negative numbers since I want my middle number to be negative. But I'm going to still list all my factors so that I have all my options to look at. Then I'm going to say, okay, 2 times 6, which also means I have negative 2 times negative 6. Then 3 times 4, and now 3 and 4 are right next to each other, so I know I've found all my factors, but I also want negative 3 and negative 4. And now I want to look at all of my factors, and I want to add them together and see which one will give me negative 8. So when I add them together, if I do 1 plus 12, I'm getting 13. Not going to work. If I do negative 1 plus negative 12, I get negative 13. Still not what I'm looking for. 2 plus 6 gives me 8. Well, I'm getting closer, but I need a negative 8. Negative 2 plus negative 6 gives me negative 8. So because negative 2 and negative 6 multiply to be positive 12 and add to be negative 8, those are the two numbers that I can use to factor this. So I am able to get a solution here. So when I go to factor it, I know I want 2 sets of parentheses. I'm going to take my x squared and I'm going to break it basically in half. I'm going to take one x and put it in the first parentheses. I'm going to take the second x and put it in the second parentheses. So each parentheses will start with an x. And then I'm just going to use my 2 factors, my negative 2 and my negative 6. Now, if I wanted to check myself and make sure that I factored it correctly, the opposite of factor is FOIL. So I could go back and check myself by multiplying this all the way through and say, okay, x times x gives me x squared. X times negative 6 gives me negative 6x. Negative 2 times x gives me negative 2x. And negative 2 times negative 6 gives me positive 12. When I combine my like terms, I get x squared. Negative 6x minus 2x gives me negative 8x plus 12. And now I'm back to, this is the same thing that I started with. So I know that I did my factoring correctly. So you can always check yourself if you're not feeling super confident in your answer, or you just want to make sure you set it up. You can always check yourself by foiling it, and you should get back to the original problem if you foil it. But you don't, that's just so you can check yourself. So our final answer here for our factored form would be the x minus 2 and the x minus 6. always first looking for factors that multiply together to get our last number. Once we've got all our factors, then we're checking to see which one adds, which set of factors add together to give us our middle number. And then we just break up our two parentheses using those two factors that we've picked out. So let's try another one. So if I want to factor x squared plus 4x minus 21. I want to find things that multiply to negative 21 and add to positive 4. Multiply to negative 21, add to positive 4. So now, again, I'm working with a negative, so I know when I'm looking at my factors, I'm going to have to include negative numbers. If both of my numbers were positive, like they were in the first one, that's why I didn't have any negatives in my factors. But in order to get negative 21, I'm going to need negative numbers. So I need factors of negative 21. So again, I'm just going to start with 1. 1 times negative 21 will give me negative 21. But I also know that with negative numbers, I can switch them. So I could also have negative 1 times 21. Both of those would give me negative 21 when I was multiplying. Does 2 go into 21? No. But 3 does, right? 3 times negative 7, which also means I could have negative 3 times positive 7. 4 doesn't go into 21. 5, 6 doesn't. And now I see that I've already used 7 as a factor, so I've used every possible number. I've checked every possible number for factors. Now I need to go through and see which one adds to give me a positive 4. So if I do 1 plus negative 21, it's really like saying 1 minus 21 gives me negative 20. Negative 1 plus 21 gives me positive 20. 3 plus negative 7 gives me negative 4. Negative 3 plus 7 gives me positive 4. So the factors I want to use are negative 3 and positive 7. Because negative 3 times positive 7 equals negative 21 when I multiply them. And when I add them, I get 4. So I've checked off both my boxes. I've got my multiply, I've got my add, so I can factor it. So I'm going to split up my two sets of parentheses. They each get an x. And then I'm going to say, okay, it's a negative 3. And since it's a positive 7, I'm going to write plus 7. Because I don't want to just leave it as a blank space with an x and a 7. Since it's positive 7, I use a plus sign. So my final answer is going to be x minus 3 and x plus 7. Do you want to try another one together? Or do you want to look at your classwork and work on that together? Look at the classwork? Okay.